It's my pleasure to introduce our closing speaker for this symposium, Dr. Patrick Aderkas from the University of Victoria. Patrick and I have worked together occasionally over the past few years on a few projects, most of them related to reproduction in lodgepole pine. He helped us investigate issues with poor seed set in our seed orchards in British Columbia and options for stimulating flowering. But his real passion is conifer reproduction and the evolution of sexual fluids in plants. We asked Patrick to impart his wisdom on the students and young research participating here today in planning their futures and their future careers. So his talk is titled, "The Hurrier I Go, the Behinder I Get, How to Better Plan Your Career in Forest Genetics or Any Career." Over to you, Patrick.
Okay. Well, thanks to everyone for a great conference. Now, I just love the fact that this is for grad students and for postdocs. That sort of covers the best and I would say the worst time of my life. It was good because I had lots of time to think and it was free to think, but man, was I poor. So for everyone here, it's been the weirdest of years. I emptied out my lab, graduated my final PhD and my final master's student, finished off final postdoc. And, you know, I know that for them, it's been a strange year in terms of job prospects, in terms of social life, and they've all suffered from massively increased anxiety. But this too will end. I got my jab the other day, so the horizon is looking much nicer. So thanks for sticking around to listen to this at the end of the conference. I'd like to thank the organizers who invited me to talk. Being the last speaker in a conference has been something that's happened to me about half a dozen times in my life. And I have to say it's my preferred slot. You can say almost anything. There's less pressure than certainly being the opening speaker. And I hope I can finish off with some useful insights that will help you think about your own careers differently. And if I succeed in making you smile about life in academia, then I will have accomplished my goal. So the title here, "The Hurrier I Go, the Behinder I Get, How to Plan Your Career in Forest Genetics or Any Field." Well, the quote is from Alice in Wonderland. Obviously, it's that old, feeble, shilly-shallying type of character, the white rabbit, who worries about being on time. And in this case, he's worried about being on time to the Queen of Hearts party. And if he doesn't make it on time, it's off with his head. But I didn't choose it for that reason. I chose it because it's based on something in academic life. And that is unusual. Like, we're not beholden to anyone. Academics are their own masters. It's kind of an odd career. Think about it. I've never had a boss. What sort of employment is that? Ideal. However, and here's where the hurrier I go and the behinder I get comes into it. We're also the architects of our own undoing. It goes without saying that a career without a boss is easy to mismanage. Managed or mismanaged depends on how you value, I guess, research and the scientific method in your work, and whether you use it to drive beyond your current work and your studies into something new. So, put differently, what does it take to stay ahead, and how do you prevent yourself from falling behind? So let's see how this shilly-shallying old white bunny got on with it. So let's put my career under the lens here. I finished my undergrad when I was 23. I finished my PhD under Elizabeth Cutter at the University of Manchester in England when I was 26. And here you can see me at the electron microscope in Manchester. I think I just hit puberty there. So I graduated at an inauspicious time. I would even call it a grim time. Margaret Thatcher had just come to power, and she really ruined British universities for a generation. And it wasn't any better in North America. In 1980, there were 400 PhDs granted in astrophysics, and there were 2 jobs. So it meant that I went through, basically in my field as well, years of postdocing. First, I spent 4 years at the National Research Council in Halifax in Nova Scotia, working with Jack McLachlan. And then I spent 4 years at the Canadian Forestry Service with a couple of well-known individuals. And to my right is Jan Bonga, who's one of the premier tissue culturists, not only in Canada, but in the world. And to my left is Don Fowler, who's a very well-known spruce and larch breeder. And in 1989, I landed the big one. I was hired at the Center for Forest Biology at the University of Victoria. I had interviewed for a number of other jobs and I didn't get them. But this one I knew was working really well, like was going to go swimmingly as an interview process, because no one asked me about the wealth of papers that I'd written about ferns. Did you notice the organisms at the bottom? First, a PhD on the king fern, Todia barbara, followed by a postdoc on the fiddlehead fern, Matutsia struthiopteris. This was a recipe for academic suicide. Fortunately, the tissue culture skills that I developed with ferns saved my sad little ass and made my transition to cloning haploid larch much easier. So a few more conifers that I've beat up over the years include other larches, Douglas-fir, lodgepole pine, and most recently last week, I had a paper appear on Sitka spruce. So it's funny to think about the career and how it replicates evolution. From ferns to gymnosperms to a few recent papers in angiosperms, especially on angiosperm nectar proteomics is a recent interest. Even if my start was unconventional, and it was nearly over before it began thanks to ferns, the career otherwise was very conventional. And what I mean by conventional is that switching fields is normal. And those of you who went to the career thing this morning, where various people described their own personal arcs, you know, through their own narratives of how they developed as scientists, it was universal that everybody had switched from this to that, to that, to this. And eventually all of those skills coalesced into a very powerful program. So what does it take to stay on top? If I just trace the history of the use of methods, including some from different sciences, many of which I really did get a high degree of mastery in, others not so much, it looks something like this. Boring old fern tissue culture on the bottom left-hand side was a springboard to develop experimental tissue culture. And that led to dozens of papers in gymnosperms. That was really my bread and butter for a while. In the 1990s, plant growth regulators, or plant growth regulator metabolomics was basically enzyme-linked immunosorbent assays. And I sort of went to France to master those and came back, and that gave me the confidence to switch to mass spectrometry and then move into MRM, tandem mass spec, and absolute and relative quantitation of plant growth regulators. And that led to what Nick was alluding to, working out methods to put more cones on trees, for example. So all of this was brought to bear on reproductive questions. So technology, you embrace it, and if you master bits of it, then it's like a golden chain. One link pulls along something else. No, I wasn't born a biochemist, nor a chemist. My PhD was in plant anatomy, for God's sake. So let me give you advice on how to move along the interfaces of different sciences. That's a rich area, by the way. The first thing is to learn how to do it. And there is no better way than to go to a lab that does it. Learn at the lab bench of the masters. So it's no good if you haven't read the theory and you don't understand the theory, or you don't make the theory work for you. But it isn't that hard either. I would recommend, although it is humiliating, and I did this to learn proteomics, take an upper level undergraduate course, or at least audit one. Hey, getting spoon-fed by a good prof is a quick route to understanding what's going on in the test tubes. So be prepared to screw up a lot. Trial and error is a great master. Just do it. Now, this is only possible if you're kind to yourself. So be patient with yourself. Don't beat up on yourself. I know that a lot of you might think, being grad students yourself or postdocs, that the boss is always using you as cheap labor. But that comes with a risk, even if it is true. And the risk is for for supervisors like myself, that the talent runs out the door, the techniques run out the door, the lab books are incomprehensible if you don't know how these things actually work. So after 8 years of postdocing, I did have a benefit because I was completely self-sufficient. I had already built up a massive network of professionals that I could rely upon. And so I gave my students much more freedom to develop themselves. And I wasn't sitting on them for their papers. It wasn't going to make or break whether I got a grant or whether I got more money. So that's an interesting thing, and that's a different approach to it. Now, another way to overcome any bottleneck in science that you might have is to teach others, get people to come in from abroad, from Italy or from France, and work in your lab. I think sharing materials and sharing technology is really important and understated and undervalued. It was Jan Bonga who said to me that scientists were of two types, those who shared and those who didn't. And sharing gets a hell of a lot more done. And then the last thing is something unusual, building a community by providing resources, which sounds like window dressing, but it isn't. So here's my website. And if you look in the pollination drops and nectar, you'll see that there's a link to almost all the pollination drop publications from 1841 to 2021. In fact, that's all the ones that I'm aware of. And I update it all the time. And so it's available to anybody who wants that document. And it starts with the first paper that was ever produced that ever mentioned pollination drops in the history of the world, and that's by Fauché in 1841. And it runs all the way through to the last decade and most recent things. Now, what's interesting about this is I get emails. I get collaborations on account of that link. I attract students. I only discovered how well this works late in my career, and I wish to God I'd done it earlier. You'd be surprised. You go to a conference and you run into people who have downloaded that information and are completely grateful for it. You get a reputation for being helpful, and that definitely helps more than citation index in attracting attention, for sure. Speaking of silly metrics like citation index scores, I mean, this is the thing that's so unfair. You're young and yours are low, and I'm old and mine are high. And they only went up because I got older. Like, it's dumb. So see what happens when you write a book. My chair in my department said, Patrick, a book is only worth one paper. And he was so wrong. What a book does is, if it's effective and it teaches people how to master a difficult subject, it burnishes your reputation in ways that citation index never will. So it's interesting how you can approach these things. Now, of course, you can't succeed unless you read voraciously. And I'll read articles, I'll read almost anything, frankly. I'm indiscriminate in my reading habits. I will actually say that some books have poked me into the darker corners of plant reproduction and have taught me a lot. So don't turn your nose up at old people's musings here, like, Mary Wilson and Nancy Burley's. Those are wonderful books, and they make you think about things differently. You see how things have advanced, but you see where the questions are that have never been answered and that still need to be tackled. So the next question is, how do you prevent yourself from falling behind? Because that's the white rabbit's other problem. And I think it's really simple, that you just have to manage time and ideas. And what I mean by this is, you need to carve out time to think. And generally, you need a 6-day work week if you're going to succeed in this. There's a lot of pressures that are put on you in academic life. There are lots of unreasonable demands, and there's teaching, and there's committee work, and there's this and that. So if you want to think, you need to find an extra day. So how do you do that? And here is my method. This is going to be the von Aderkas method. I wouldn't use it. It's not good for anybody except me, but I stick to it religiously, and it does really work. Monday is bureaucratic Monday. I work late. I clean out that stable of bureaucratic garbage. I try and knock my email back to zero. I try and get committee reports written. I try to get a lot of the paperwork just done. I might not even touch a single thing that I'm doing. I might not touch a paper, a revision, page proofs. It's all about what goes on at work that I have to get done so that I can clear up some time for later in the week. So Tuesday I work late, usually on my own stuff, if I'm lucky. Wednesday, I definitely work late on my own stuff. And then Thursday, I work a normal day and stop at 5. And then my wife and I usually, well, certainly pre-COVID, would invite friends over, and then we would have an enjoyable evening. Friday, I never worked later than 5. I mean, it's the weekend, folks. And so Saturday, I kept for myself and family, and Sunday, I kept for myself and family. But you see those 3 late evenings equal 1 extra day, and they're front end loaded in the week. So by the end of the week, I'm actually not totally burned out. And by the weekend, I have time to recover, to get ready for bureaucratic Monday. So I save the garbage for the beginning of the week and then try and slide down the slope of work to a happy ending. Now, those are just the mechanics of careers that, are taken care of. And we really have to come to the crux of what we do. And that is what we love to do, which is to develop ideas and hypotheses. So one way you can think of this is, that you think of an idea that is relevant to past ideas. So in math, it would be like Fermat's theorem or something like that, that keeps those guys locked down. But in plant biology, it's haploidy and diploidy and evolutionary questions, and they speak for themselves. If you're interested in the present, then you apply technologies to questions about adaptation or about the basis of ecotypes, physiology, and things like that, just to show you that there are these things. But when you think about the future, it's different. You have to ask, what do I want to be doing in 5 years? That's a personal question. And for me, that is an important one because there's not much future left. If you're interested in ideas, then you'll be interested in creativity. But I find creativity very personal. How do I get a good idea? How do I get a really good idea? If you get a good idea, you won't get a nickel for it unless you start the process of the baby steps of publishing in that field. And if you don't publish, it's not you who perishes, it's your ideas. So let's see how ideas skip across from humble origins to a nice result. So I started at UVic with experiment I was hired as a tissue culturist actually. So I worked in experimental tissue culture, and here's an imaginary test tube with pollen, and I want to get the pollen to germinate in vitro and fertilize that megametophyte. And so we did this with Douglas-fir, and it took 4 PhDs, and that's way too hard. That is like really hard. So that led to the natural question, which is, how does the plant do it? And I was an anatomist, so I was perfectly aware that all we knew was the anatomy and morphology. And when it came down to it, we knew very, very little about the actual process. So it was a question of dissecting it and pulling it apart and working on it. And so, like a good anatomist, I started to pull these things apart. And then we found that in these pollination drops that are actually accepting the pollen, on a thing like, I don't know, a juniper or something like that, that in fact, when it recedes into the ovule, it leaves stuff. We didn't know what the stuff was. We could see it in the electron microscope. So the question was, what is it? And at that point, I had to leave anatomy behind and work on different things. So we began collecting those little drops, and they're truly miserable, 30 nanoliters each in Douglas-fir, 10 nanoliters in Camus Paris. And you got enough of that together so that you could whip them through a mass spectrometer. And we found that this way we could identify proteins from pretty small collections, actually. We also used HPLC to identify amino acids and carbohydrates. So now we have 2 sort of classes of compounds that we know something about in this reproductive system that people didn't know about previously. And it turns out those proteins were largely defense proteins. Typically, there were things like chitinase. And we know that they actually function in the drop because in-gel assays confirm that. So the defense proteins is actually a safe sex story. Gymnosperm ovules are open to the outside. They have to be, they're not discriminatory, but they better do something about microbes that are coming in. And then the sugars we found were mainly fructose, glucose, or sucrose. So what we did then is we went big. We surveyed extant clades of gymnosperms. I drew in lots of people from around the world to help on this, to help collect, to help with analysis. And we discovered that defense proteins were universal in pollination drops. And the sugar analysis gave us the evolution of nectar in gymnosperms. I know that some of you don't think that gymnosperms have nectar, but if you have a pollination drop and it's mostly sucrose and it's attracting insects to do the job, that's an ecological service, and trust me, that's nectar. So the story that was revealed by this was quite new and quite different. And it made us think about reproduction differently. So clearly there's a biochemical evolution to defense in ancient seed plants. I mean, when you go back to the first gymnosperms, cycads and ginkgos, they're not very different from teratosperms. You know, there's the step that everything takes. And it's not just about capturing pollen, it's about capturing pollen in a dirty ancient world. And that makes you think about a bigger question. How did the division of labor in defense evolve in haploid and diploid tissues that are now fused to form this thing that is going to be the ovule and that's going to be eventually a seed? And that is the biggest revolution in plant development on the face of the planet. So it's a very fundamental question, but we've begun to poke away at it. And it was all because of a rather shabby experimental tissue culture experiment that seemed like an enormous waste of time. And then 20 years later, we have a much deeper appreciation of how sexual fluids play a role in gymnosperm evolution and seed plant evolution. But none of this is possible unless you have collaborators. They really do make the world go round. And among those collaborators are surprisingly people that I've been working with for an enormous amount of time. And Jan Bonga, I published with for 30 years. René Rohr and Marianne Lou Walters in France, 25. I'm now coming up to the 15th year anniversary of working with Massimo Neppi at the University of Siena. Others have been short and sweet. Working with others is a pleasure in my books, and it yields dividends, including friendships. It isn't just collaborators that made my career a sunny one, but students and postdocs hold a particular place in my heart. And you know, here's a list of people that have gone through my lab. Now, I'm really proud of the work that that the graduate students and the postdocs have done. And let's just pick the latest unpublished stuff from the lab to show you why. So Andrea Coulter, my last PhD student, she actually got around to doing experimental tissue culture, which now you know is a familiar theme here. And she decided to do nucellar cultures, which is really a very unique thing to try to do. And she managed to be able to produce chitinases in vitro in fermenters. And we verified those by mass spectrometry. So that's a big advance. That means that we can avoid or forego collecting chitinases, you know, out of drops. I mean, you have to be nuts to do that work. Then my postdoc, Stefan Little, he was really interested, and I'm really interested on, you see that big giant sperm right in the middle there, and beside it is a little stripling of a human sperm. I mean, it's just nothing. So here we have these huge cycad sperm with somewhere around 15,000 flagellae, and they have to swim. And they have to swim on a liquid produced inside the ovule. These aren't pollination drops that are produced from the inside and that come outside to capture something. These are liquids produced inside an ovule. So needless to say, no one studied them. It's a total misery. But we figured out how to do it with Takashiro Takaso in Japan. And so now we've done the analysis of that chamber fluid. It's called the archegonial chamber fluid, a terrible name. And now we've begun to analyze the proteins and the sugar content, amino acids, and a number of other things. So it's sort of revealing some of the early steps in evolution, if we believe that extant gymnosperms are actually still doing it exactly the way that they were doing it all those hundreds of millions of years ago. Dr. Marie Vance, a student of mine, worked on population genomics of subalpine larch. She had possibly some of the most beautiful collecting trips in the history of forest genetics by having to climb on every mountaintop wherever there was a larch. So this is wonderful work. Well, what's the secret of success on a forest genetics type career? Well, the answer is, you know, you do it tree by tree, idea by idea, or in my case, cone by cone. So good luck to all of you and much continued joy and success. Thank you. Can't hear you, Nick.
Great, thanks so much, Patrick. I think if we were to follow your example and just work hard and be a good person, we'll get far in life, just like you. So go ahead and folks, just go ahead and put some questions in the Q&A section. We probably have time for one or two. I've got one here to start off for you, Patrick. So when you were that young chap there sitting in front of the electron microscope, just getting through puberty. Think back then, did you achieve what you thought you might at that stage in your life and in your career? Like, did you always think that you were going to be a successful professor in a big university one day?
Oh, no. Oh, not at all. In fact, I have to say that perhaps I'm even shallow. I did what I enjoyed. I enjoyed working on ferns. It wasn't like a passion from childhood, but it was something I discovered in third year university and thought that was really cool. And so then I ended up doing an honors. And then from there, it was doing a PhD. And then I realized that that was a dead end. And then I just had to find something else that I enjoyed. And so a lot of it was motivated by enjoyment. I happened to have really lovely people to work with, like Jan Bonga. I mean, that was so much fun. And so that sort of set me up. And I still have to say that if you're enjoying it, then that's the key to a lot of happiness in this career. You know, getting up in the morning going, I've got this interesting project, I've got an interesting job. And if it isn't, then you have to ask yourself why you're doing it, for sure, for sure. You only live once, so.
That's good advice. Another question I had. So I know I may not look like it, but I just finished a PhD too about a year ago. I know I look older than I actually am. No, not true. If you count the number of wrinkles and multiply by 10, you can age a person quite quickly that way. But anyways, Patrick, I find that students get really bogged down in their individual projects and the kind of systems they're working in. But what other types of skills should students be looking at getting out of their grad studies?
Well, the biggest one, and they all have it, everybody who went to this conference has it, which is that they're flexible. When they look back on where they started, even a couple years ago, and where they are now, they've had to adapt, they've had to change. And that's the key to total success in academia, which is, you work with one thing, then you learn something else, you master something else, and then you try it, and and if you don't like it, you move on to something else. But because you have a basis for being confident about being able to learn something, you can't go wrong. Like, you can't go wrong in life, period, because you've been brave enough to do that. And often for most of the people in this conference, they've gone to somewhere else to do it. They've actually had to uproot, move out of their comfort zone, and then learn things out of their comfort zone. And I have to say that's a huge plus in life.
Great. So we've got another question here. What was your biggest academic challenge once at UVic? Was it funding? Was it politics? Something else?
I think it was running a lab effectively. I think that's most young scientists' problem. You have to find the right people. And I always kept it small. I kept it 2 students who I spoiled the hell out of. Because they work really hard when you do that. You don't have to ask anything of them. They are already very grateful that they're getting spoiled. They can go to any conference in the world. So that was the key, was letting them a lot of freedom. And then, if they needed to know something, you sent them to that lab to learn it. But learning how to do that at the outset was tricky, because, you're trying to balance money, you're trying to balance a lot of things. But in the meantime, I kept, all my previous relationships running and my publications running with, other people that I knew from before. So setting it up for grad students to make them happy took a bit. That was the hardest thing, I think, making grad students happy at the beginning. At the end, it was like a lot easier. Yeah. Because happy grad students drag in other happy grad students afterwards.
Yeah, that's very good advice. Thanks, Patrick. So on that note, I think we'll close there. Thank you, Patrick, very much for being our closing speaker. Next up will be the award of the various prizes that we have. So be sure to click on the link for the closing and the awards, and we'll see you there in a bit. Thanks.